We're going to show you all the steps for you to get juvenile of sea cucumber for your farm. The first one, the material you need. The second one, the preparation of the breeders and the stimulation needed. The spawning. Then you will have the collection of the eggs and the preparation of the tank, larvae tank. And we will finish by how we feed the larvae and how we take care of the tank to be able to get juvenile more or less 1 month after spawning. For sea cucumber reproduction, the first we need some tank. 1000 liter, 200 liter, 500 liter, or whatever size to do the production. With the tank you need air, aeration. You need clean water, treated, filtered. You need some small equipment, bucket, jar, a mesh, 60, 70 micron, thermometer, something to heat the water, so a heater like this, or you can use boiled water directly, it's not a problem, and dry algae, spirulina, sargassum, a mix of the two, it's not a problem. With all this, you can make the reproduction, you can collect the eggs. After, you will need some tank like this one for the larvae rearing.
Sea cucumber reproduction can be done throughout the year in tropical areas. However, special heed should be given to the moon cycle. During a full moon, breeders will be more responsive to stimulation and release their gametes, hence spawning will occur. Broodstocks are collected from local sea cucumber farmers in natural environments or from the wild a couple of days before the full moon. Each reproduction batch should be of 50 to 150 individuals. The size of broodstock can vary between 200 to 700 grams. Bigger sandfish with a weight of more than 400 grams are ideal to optimize the number of potential eggs per individual. However, the heaviest ones will react less to stimulation and will make the hatchery spawning uncertain. Therefore, it is recommended to have the heterogeneous group with some smaller and some bigger broodstocks to optimize the responses to stimulation. Sandfish should be plump, heavy, undamaged, with no visible skin lesions and without parasites. Skin appearance should be smooth and shiny with a thin transparent mucus layer. Animals should react when touched and disturbed. The collection is done early morning or late afternoon to avoid high temperature variation during transportation, which may trigger evisceration. Be gentle with them and always manipulate them individually. Broodstocks are placed in holding tanks with treated water 40 to 50 centimeters deep and moderated aeration in a density of up to 8 per meter square.
Primeiro, os animais são colocados aqui por 24 horas, onde eles sofrem o processo de depuração, onde liberam toda a matéria orgânica que tem dentro de si.
A night of a full moon will be selected to have a high response to stimulation. The team will wait for sundown to start spawning stimulation through artificial induction. There are various ways to induce spawn. Here, 3 methods will be used: desiccation, thermal induction, and food shock. These methods are reliable and easy to implement, especially for small-scale hatcheries. The first induction is desiccation. Sandfish are rinsed and placed on a support alongside each other. The objective is to induce stress and stimulate them. They will be kept out of the water for 45 minutes to an hour.
Aqui nós colocamos os animais para descansar por 1 hora, onde, como podemos ver, eles liberam a água que sobrou dentro deles. Então, ficam aqui a descansar por 1 hora antes de serem transferidos para os tanques.
While the broodstock is desiccating, a tank is prepared with hot and filtered water. The water should be around 5 centigrades higher than the ambient temperature for thermal stimulation. Water level in the tank must be 10 to 15 centimeters and have less volume and faster heating. Increasing the water temperature is effectively done by preheating enough seawater in a cauldron or vat, then evenly mixing it into the tank until the desired temperature is reached. Heating can also be done using electric heaters, as done in this case. Aeration in the tank helps in mixing. It is important to be cautious that the elevated temperature is not above 37 centigrades, as this can adversely cause extreme stress to the animals. In the same tank, algae are prepared to induce food stimulation to increase spawning success. This is done by introducing concentrated microalgae in the tank. The most commonly used food is the commercially available spirulina powder. The dosage is 0.2 to 0.3 grams per litre of water. The algae powder is mixed in a small bucket before being mixed in the tank. When the water is at the desired temperature and presents a dark green colour, the second and third stimulation can start.
E assim promover choque térmico aos animais para que eles possam fazer a reprodução.
The breeders will be placed gently, successively in the warmed water with algae. They will stay for 45 minutes to an hour in this thermal and food induction tank. During this interval, spawning tanks are prepared with clean and treated water 50 centimeters in depth. It is crucial for the water to be filtered and treated because it will be in contact with the eggs. The water in the spawning tank will be at ambient temperature. After the second and third induction, the animals are collected successively and gently handled. They are thoroughly rinsed with ambient temperature water, cleansing them. They are then placed into the spawning tank. Once the stimulation is finished, spawning can occur. If the animals are in good condition and their gonads are mature, they can lay eggs within an hour of stimulation. However, if the animals are in poor condition, spawning may take above 2 hours or not at all. While waiting for sandfish to spawn, it is crucial not to further disturb them, as vibrations, shadows and reflections can disrupt the spawning process. Hence, it is recommended to reduce artificial lighting as well. Males are expected to release their spermatozoids an hour after stimulation. The male will stand up and start dancing. This will release a steady stream of white milk through the genital orifice, a small opening at the top of the front end. This can last for 3 hours. The ratio of males and females should be 1:1. However, there will be more spawning males than females. A single healthy male can spawn above 1 million sperms in 10 minutes. Too many milt-containing sperm cells in the tank can cause polyspermy, a situation whereby a single egg is fertilized by multiple sperms, leading to abnormal embryonic development, non-hatching and irregular larval development. To avoid this, spawning males should be removed before the tank gets very cloudy. A visual cue is when the water is lightly cloudy and the bottom of the tank is visible. The female lays eggs after the male, releasing the rapid ovipositor after the characteristic head bulges. Females can do 2 to 3 quick bursts, 5 minutes apart. Ripe quality eggs are characterized by pale yellow to pale orange. If the burst of eggs is whitish, they are likely to be immature or of inferior quality. mature female sandfish weighing 400 grams may release 2 million eggs, and larger 500-gram females may release 3 to 4 million eggs. When the animals stop reproduction, all broodstock is removed, and the tank is kept only with the eggs and spermatozoid, with gentle aeration for the rest of the night. In the morning, egg collection and monitoring can begin. Depending on the design of the spawning tank, eggs can be collected through a drain pipe passed through hoses, by siphon or by manual scooping. Eggs should be more than 150 microns in size, hence a mesh of 60 to 80 microns is used. A continuous flow of water is provided to ensure the eggs remain in suspension and do not settle in the net and get damaged. The concentrated eggs are placed in a collection bucket with moderate aeration to keep eggs from clumping. It is now time to observe and count them in the lab. From each collection bucket, 6 samples of 1 millimeter are taken. A microscope is used to count and observe the eggs. From the 6 countings, the lowest and highest data is rejected, and the average of the 4 remaining countings is calculated. The value is the estimated number of eggs in 1 milliliter. This value, multiplied by the total volume of water in the bucket, gives the total estimated number of eggs in the bucket. During this counting, eggs are monitored. Upon fertilization, cell division and embryonic development quickly occur. A single egg cell will develop into a 2-cell and 4-cell stage within an hour after fertilization, and a 32-cell stage 3 hours after fertilization. The following morning, the eggs may present the blastula, a spheric center embryo. Eggs should be round without deformities and not empty. Now the larva rearing tanks can be prepared. Classic larva rearing tanks are used. Tanks need to be cleaned, disinfected and filled with filtered and treated seawater to avoid media biocontamination. Aeration systems should be in place and running. Water parameters like temperature, salinity and pH must be the same for both the holding bucket and the larva rearing tanks to minimize stress to the fertilized eggs and developing embryos. The optimum water temperature for the tank is 27 to 29 centigrades and never above 30 centigrades during the larva stages. Once the total egg count and density in the holding bucket is known, the actual volume to be stocked into the incubation tanks can be computed. The stocking density of eggs in larva rearing tanks is 300 eggs per litre. Depending on the temperature, hatching will occur 16 to 22 hours after fertilization. Larva will require feeding 36 to 44 hours after fertilization. Meanwhile, the larva will use its reserved nutrients. During all larva stages, a cocktail of different algae will be used.
Essas microalgas são produzidas para alimentar os primeiros estágios larvais da holotorias. Nos primeiros estágios, usamos 4 espécies de microalgas, que são as seguintes: o caito, o tetra, o iso e o nano. Cada vez mais que o estágio avança, nos últimos estágios, usamos outra espécie de microalgas, que são as diatomáceas, podendo ser os navículos ou a ânfora.
The quantity of algae to feed the tank is calculated according to their concentration in larva tanks and will be part of daily tasks.
Diário da larvicultura. Diariamente, controlamos a aeração permanente no tanque. A aeração não pode parar, tem que estar permanente. E medimos a temperatura em cada 2 horas. Medimos a salinidade uma vez por dia e medimos a concentração da microalga em cada 6 horas de tempo. Se a concentração da microalga que precisamos for baixo, aumentamos com uma alga fresca. Se contamos e a concentração for suficiente, não precisamos de aumentar a concentração da microalga. Também, diariamente, levamos amostras da oletorias para a contagem e observação da oletorias.
During the first 2 weeks of the management of the lava tank, regular siphoning of deposits should be done to eliminate excess debris and clean the tank. Aeration will be stopped 20 minutes before siphoning to separate lava and debris. Partial water exchange using a filter will be done to maintain good quality water. The lava will go through 4 stages: gastrula for 48 hours, auricularia for up to 3 weeks, doliolaria for a maximum of 1 week, and pentacula for 10 to 20 days. Each stage will depend on the water condition, temperature, stress, and quality of reserve the lava had to pass to the next stage. When the first doliolaria stage is observed, it is a sign that the pelagic or swimming stage of the animal will end. Siphoning and water exchange will stop and diatoms algae are introduced daily. Development of fouling on the tank side is preferred as opposed to supports introduced in the tank to increase surface area for the last lava stage and the settlement of the lava on the bottom for the beginning of the ethnic phase of the animal. This is the end of the larva stage and the beginning of the juvenile stage.
Aqui é o tamanho comercial que nós queríamos ter no fim da produção. É 400 gramas, que vai levar 1 ano e meio. 1 ano e meio é totais de períodos, totais ao longo de 1 ano e meio que vai levar o desova, a criação de larva, o nurseria e a engorda. Para ter 400 gramas, que é o tamanho comercial da venda, que é nosso objetivo final.